everyone! Did you know that even though hydrochloric acid and sodium hydroxide differ in nature, both react with some metals in a similar way? Do you know what the reactions are and how they show similarity? Let us explore in this video. The objective of this animation is to study the properties of acids and bases, HCl and NaOH, from their reaction with litmus papers, red and blue, zinc metal, and solid sodium carbonate. Let us say HCl is taken in a small quantity and a few drops of it are sprinkled on blue and red litmus papers. We will observe that the blue litmus paper turns red while the red litmus paper remains unaffected. We can thus infer that HCl is an acid with a pH value less than 7. We will now study the reaction of HCl with sodium carbonate. For this, we take two test tubes which are connected by means of a delivery tube and are sealed by the corks. One of the tubes consists of solid Na2CO3 to which aqueous HCl is added and the other is filled with lime water. After some time, you can observe bubbles in the first test tube, indicating the formation of gas. As this gas passes through the delivery tube into the test tube filled with the lime water turns milky. We can thus conclude that the gas formed is carbon dioxide. Let us build a balanced chemical equation for this reaction. Na2CO3 plus 2HCl gives 2NaCl plus H2O plus CO2. Do you know which molecule turns the lime water milky? A molecular view shows the presence of calcium carbonate. Actually, CO2 reacts with CaOH twice to form CaCO3, which is white and insoluble in water. Let us now study how HCl reacts with zinc metal. Heat a test tube filled with dilute HCl to which some zinc granules are added. You can observe bubbling, indicating the formation of gas. Now bring a lighted matchstick close to the mouth of the bent tube. The matchstick extinguishes with a pop sound, indicating that the gas is hydrogen. A balanced equation of this reaction can be written as Zn plus 2HCl gives ZnCl2 plus H2. Let us observe the reaction closely. You can observe a lattice of zinc atoms and hydrogen ions as well as chloride ions in the solution. Zinc atoms lose 2 electrons, each of which is accepted by a hydrogen ion. This results in the formation of zinc ions in the solution. The 2 hydrogen atoms combine to give a hydrogen molecule which escapes as a gas. Let us now study the properties of bases. Taking sodium hydroxide as an example. To begin, add a few drops of NaOH to red and blue litmus papers. You will observe that the red litmus paper turns blue while the blue litmus remains unaffected. To conclude, we can say that NaOH is a base having a pH value more than 7. Let us now study the reaction of NaOH with Na2CO3. The two test tubes are connected by means of a delivery tube and are sealed by a cork. One test tube is filled with Na2CO3 and NaOH solution, while the other one has lime water. As there is no reaction taking place between Na2CO3 and NaOH, no gas is evolved. Hence, lime water remains colorless. Next, we will observe how sodium hydroxide reacts with zinc. For this, heat a test tube filled with NaOH to which a zinc piece is added. You will observe bubbling, indicating the formation of gas. Bring a lighted matchstick close to the mouth of the bent tube. The matchstick extinguishes with a pop sound, indicating that the gas is hydrogen. The reaction can be summed up as zinc reacts with NaOH to form Na2ZnO2 and H2 gas. Let's summarize. Acid turns blue litmus red. An acid generally reacts with Na2CO3 to form carbon dioxide gas. Acids generally react with metals to liberate hydrogen gas. Bases turn red litmus blue. Bases generally do not react with Na2CO3. Bases generally react with metals to liberate hydrogen gas. Do you think the bubbles are formed at the same rate even when different metals react with hydrochloric acid? Stay tuned to find out and learn more about the reactions of acids with different metals.
Keep imbibing. We believe in you.